Hello again, everybody. Mr. Reeves with you today as we explore our third and final method for solving systems of linear equations. So the first method that we learned was solving by graphing, where we would graph the lines and find the point of intersection. And that point of intersection was the solution that made both equations true, which is what we're trying to find. The second method that we studied was substitution, which required us to make sure that one of the equations, at least, was solved for either x or y, so we either had y equals or x equals. This third method is called elimination, and I have to say that generally when I teach this is my students' favorite method, especially this first day when we're doing the easier problems that just involve addition or subtraction. In fact, I often get the question, Mr. Reeves, why didn't you teach us this method first? And the reason we don't teach this method first is because conceptually it doesn't make sense as much. When you graph two lines and you're finding where they intersect, that conceptually makes sense. You're finding the point that's on both lines. When you substitute, the idea that you replace something with something that is equal to, again, conceptually should make sense for both of us. This idea that we can add and subtract equations together is something that probably conceptually wouldn't make as much sense to us, or at least we wouldn't think to do it. So that's why we usually save elimination for last. In fact, I want to just show you real quick the idea behind elimination and why it works. So I'm just going to go ahead and come up with an equation, very difficult one. 1 plus 2 equals 3. I hope you all agree that is a true equation. Then I'm going to come up with another equation. 4 plus 5 equals 9, and that is also a true equation. And now I'm going to add these two equations together. And when I add those two equations together, 1 plus 4 is 5, 2 plus 5 is 7, and 3 plus 9 is 12. And I hope you can see that when we added a true equation to a true equation, we got another true equation. And we could also do the same thing with subtraction. So I'm going to reverse it this time. I'm going to put 4 plus 5 equals 9 on the top. I'm going to put 1 plus 2 equals 3 on the bottom. And this time, instead of adding, I'm going to subtract. And let's subtract straight down. 4 minus 1 is 3, plus 5 minus 2 is 3, and 9 minus 3 is 6. Notice very carefully that I've subtracted each of these, right? I subtracted the 1 from the 4, the 2 from the 5, and the 3 from the 9. So I started off with a true equation. I had another true equation, and when I subtracted, it's still a true equation. Now, this doesn't prove that it always works, but there is a proof, and just believe me that it does. So this shows that if you add a true equation to another true equation, or if you subtract a true equation from another true equation, you get a true equation. One more thing I want to show you here. This time I'm going to make an equation. X plus 3 equals 5. All right, so what is the answer to that equation? Actually, let me change that. X plus y equals 5. All right, do you agree that 2, 3 is an answer to that equation? 2 plus 3 is 5. You agree with that? All right, so now I'm going to come up with another equation where 2 and 3 are solutions. What about 2x plus 3y? Now let's try this real quickly here. 2 times 2 is 4, 3 times 3 is 9, and that's 13. So do you agree 2, 3 makes that first equation true? 2 plus 3 is 5. 2, 3 makes that second equation true. 2 times 2 is 4, 3 times 3 is 9. Now I'm going to add those two equations together, and let's see what we get. X plus 2x is 3x. Y plus 3y is 4y, and 5 plus 13 is 18. Now let's check it with 2, 3. 3 times 2 plus 4 times 3. What do we get? 3 times 2 is 6. 4 times 3 is 12. And what is 6 plus 12? It's 18. So not only when you add a true equation to a true equation do you get a true equation, if you add an equation that has a solution to another equation that has the same solution, that third equation will also have the same solution. And guess what? If we change this to subtraction, we'd get the same result. We'd get a different equation, but it is also going to be true. So let me show you real quick here. We're going to get some negatives, but that's all right. 1x take away 2x is negative 1x. 1y take away 3y. Remember, we're subtracting here, not adding, right? Is going to be negative 2y or minus 2y. And 5 take away 13 is going to be negative 8. Now, if I put 2, 3 back into that equation, negative 1 times 2 minus 2 times 3, what do I get? Negative 1 times 2 is negative 2. Minus 6 is what? Negative 8. It works. So what I've just shown you, I hope you understand the process there, is that when you add equations together or subtract equations together, you get a result that's a new equation, but it does not change ultimately the solution set. In fact, if it was a solution to the first one and a solution to the second one, it will be a solution to the third one. So that's why we can use this last method. All right. If you did not understand any of that, guess what? You're okay, because all you have to do is understand the method, but I was just trying to show you conceptually why it works. All right. So let's go ahead now and let's just dive in and let's do some problems. All right. So I'm going to take a look right here at your turn. So I'm on page 248. Actually, I'm going to go back. I'm going to go back here to right here. Okay, so now I'm on page 246, and let's take a look at these two equations right here. So my goal is to solve. Remember, solving a system is finding the value of x and y that makes both equations true. So we're looking for an x and a y that will add up to negative 1 and subtract to equal 7. Now we could graph these lines and see where they cross, or we could use the substitution method, but we're going to try to use elimination. Specifically, we're going to use for these problems addition. And how do I know we're going to use addition? Well, they told us to use addition. All right, but I'm going to show you why we're going to use addition. All right, well, let's just see what happens when we add these equations together. X plus x is 2x. Plus y and minus y, what's going to happen to those two? Those are opposites, so they're going to cancel. And then I get 7 plus negative 1 is 6. All right, we'll come back to this problem. I just want to show you a pattern that's going to occur here. Again, when I add these two equations together, 2x plus 3x is 5x. These two are going to cancel, and I'm going to get 5x equals, and negative 2 plus 12 is 10. And then I'm going to come over here, and I'm going to add these two equations together. 6x plus negative 6x, those are going to cancel. Here we go. 5y plus 7y is 12y, and 4 plus 20 is 24. So do you see what happened on each of these? What did I start with? I started off with two equations with two variables, right? Two equations with two variables. Two equations with two variables. But after adding them, what did I then have? One equation with one variable, one equation with one variable, and one equation with one variable, right? X and y, just y. X and y, just x. X and y, just x. That's why this method is called the elimination method, because when we do this method, what happens? We eliminate one variable. And when you eliminate one variable, then you can solve that equation and find the value of the variable. Not only are we eliminating one variable, by the way, we're also eliminating an equation. We're not really eliminating the equation. We're just producing that third equation. Remember what I showed you in the intro. If it makes this equation true and this equation true, it's also going to make this one. So we're creating an easier equation that we can solve, and then whatever solution we get here is going to work up here. Does that make sense? Now, why did addition make this happen? This will not always occur. First time I show this to students, they go, oh my gosh, that's so easy. But I have to warn you, this doesn't always work. This method of adding only worked because these two were opposites. Because these two were opposites. Because these two were opposites. The addition method works when you are adding opposites. Why? Because adding opposites always equals 0. Adding opposites always equals 0. What is 7 plus negative 7? It is 0. What is negative 14 plus positive 14? It is 0. What is a positive x plus the opposite of x? It is 0. You'll always get 0. So when you see that you have a pair of opposites, that is your clue. They're not always going to say add. They were really nice to tell us to add because this is an introductory lesson. But they're not always going to tell you to add. You're going to have to look for that. And when you see that, you're going to go, hey, those are opposites. I should add. Hey, those are opposites. I should add. Hey, those are opposites. I should add. And now, since I have just this one variable, I can go ahead and solve this equation, and I get x is 3. Or I can go ahead and solve this equation, and I get x is 2. Or I can go ahead and solve this equation, and I get y is 2. Now remember, we're looking for an x and a y. So far, what do we have? We only have half of our answer. And make sure, by the way, you're putting it in the correct spot. These two we found x. This one we found y. So we're going to go ahead here and put in the value of y. Now here we still have to go back and find out what y is, right? We don't know what y is. We don't know what y is, and on this one we don't know what x is. So how are we going to figure it out? Well, we're going to figure it out the same way we did in substitution method. When we knew what one of them was, we go back to our equation and we plug it in. Now, remember, this is going to make all of our equations true, right? So if I go back to number 3, my first equation was x plus y equals negative 1. My second equation was x minus y equaled 7. And that third equation that we made was 2x equaled 6. All right? So what do I now know? I now know that x is equal to 3. Well, putting 3 into this last equation isn't going to help me. All it's going to do is prove that that's correct, right? So I'm not going to use that last equation. But I can use either one of these equations. X plus y equals negative 1. So x is 3. I'm going to go 3 plus y is negative 1. If I subtract 3 from both sides, I get y is negative 4. Right? What about this one? X minus y equals 7. So again, x is 3. 3 minus y equals 7. If I subtract 3, I get negative y equals 4. So for this one, I also get y equals negative 4. So 3, negative 4, now I can go back and plug that in. 3, negative 4 is the solution. It is the ordered pair that makes both equations true. All right, does that make sense? So if we go now to this second one up here, I'm going to go ahead and erase this. It's like my whiteboard down here. All right, so now I know x is 2 for this one. So I have that first equation, 2x plus 2y equals negative 2. And my second equation was 3x minus 2y equals 12. Again, that third equation I have, 5x equals 10, that's a true equation, but that one's not going to help me because it doesn't have a y in it. And remember, my goal is to find y. So let's just go ahead and use this first equation. Again, we know that x is equal to 2, so I'm going to go 2 times 2 plus 2 times y equals negative 2. Well, 2 times 2 is 4. 4 plus 2y is negative 2. When I subtract 4 from each side, I get 2y equals negative 6, which tells me that y is equal to negative 3. So now I can go back here and replace that question mark with a negative 3. And guess what's going to happen? If I put this in this equation, I'm going to get that real quick. 3 times 2 is going to give me 6 minus 2 times negative 3. Well, 2 times negative 3 is going to give me a negative 6. But subtracting a negative is the same as adding a positive. What do I get? 6 plus 6 equals 12. What was I supposed to get? 12. So that proves that 2 negative 3 makes both those equations true, which proves that it is the solution to the system of equations. All right, last one here. Again, we added these equations together. This one was different though, because this one, when we added the two equations together, we eliminated the x, so now we know what y is. So if I go up to that top equation, it is 6x plus 5y equals 4, and the one below it is negative 6x plus 7y equals 20. But what did we find out? We found out that y was equal to 2. It's very important you pay attention to which variable you have solved for. This one was y, right? These ones were x. So these ones I knew x and had to find y. This one I know y, right? And I have to find x. Okay, so I'm going to go to this equation. I know that y is 2, so I can use this top equation or the bottom equation. I'm going to go ahead and use this top equation. I'm going to go 6x because I still don't know what x is, but I'm going to go 5, but instead of y, what am I going to put? I'm going to put 2. So here we go, 6x plus 10 equals 4. Now I'm going to solve that equation by subtracting 10. 6x equals negative 6, so x is negative 1. So now we can replace that question mark with a negative 1. So now I'm pretty sure that x is negative 1 when y is 2. Now let's do a quick check down here at the bottom because that's what good math students do. They always check their answers. Negative 6 times negative 1 plus 7 times 2. Let's see what happens. Negative 6 times negative 1 is 6. 7 times 2 is 14. 6 plus 14 is 20. What were we supposed to get? 20. What did we get? 20. So that proves that this makes both equations true. So just to review, we're learning elimination. The first part of elimination involves adding two equations together, and this method of addition only works when you have these pair of opposites. When you have these pair of opposites, after adding, you're going to go from two equations with two variables to one equation with one variable. You solve that equation, you get the value of that variable, then you substitute back into one of those two equations, doesn't matter which one, and you will get the correct solution. And then a good math student will go back and check his or her answer in the other one to make sure it's true. So that is elimination by addition. That's elimination by addition. Well, as I told you before, it doesn't always work. So I'm down now on page 248. All right, so we're going to do a very similar thing to what we just did, but you'll notice the directions now say to solve by subtracting. So I'm going to pretend for a minute I was not good at reading the instructions, and I thought I was still doing the other types of problems, and I'm going to add them. So let's see what happens when we add them together. 6x plus 6x is 12x. 8 positive y's plus 3 negative y's is going to give me 5 positive y's. And 16 negatives plus 6 positives is going to give me 10 negatives. Excuse me. So if you notice what happened, when I added them together, I got a third equation, and we know this is okay. We know this equation will still be true if these equations are true. And we know that whatever solution worked for this one and this one will also work for this one. But it didn't help us because we went from what? Two equations with two variables to one equation, but what's the problem? It still has two variables. Do you see that? What do we want? We want, when we do this, to have one equation with one variable. Why didn't it work? Remember what we said before? You had to have those opposites, and we don't have the opposites. 6x is not the opposite of 6x. 8y is not the opposite of negative 3y. But 6x and 6x are the same. So just like adding opposites will always equal 0, right? Subtracting the same thing. Subtracting the same thing. Let me try to see if I can write that a little better here. All right, subtracting the same thing always equals 0. Subtracting the same thing always equals 0. Subtracting the same thing always equals 0. So therefore, when I see that these are the same and not opposites, I'm not going to add, I'm going to subtract. Now this is my recommendation when you're using subtraction. Put parentheses around it. And the reason to put parentheses around it, you don't have to, but it's a really good reminder that we're subtracting everything. I've seen students many times, they subtract the first one and then they add the other two because they forget that they're subtracting. So by putting those parentheses, you are reminding yourself and showing me that you know I'm subtracting this entire equation. All right, so here we go. 6x minus 6x is going to be 0x. What just happened? They canceled, right? What's 3y minus 3y? Those ones are going to cancel. 2x minus 2x are going to cancel. Again, subtracting the same thing always equals 0. So I just showed that that part is 0, that part is 0, and that part is 0. What did we just do? Remember, what is this method called? This method is called elimination, right? Because every time we're going to be eliminating one of the variables. In this case, we're eliminating the x's. In this case, we're eliminating the y's. In this case, we're eliminating the x's. All right, so let's see what else we have. Right here, I have a negative 3 minus 8. All right, now be very careful when you're doing these problems. Use a calculator if you need to. You really shouldn't need to use a calculator to do negative 3 minus 8, but I'd much rather you use a calculator and get it correct than not use a calculator and get it wrong. So do you see negative 3 minus a positive 8? When I do that, I get negative 11. So I have negative 11 y equals. Now what do I have here? Be careful. 6 minus a negative 16. 6 minus a negative 16. Remember, subtracting a negative is the same as adding a positive. And what do I get? I get positive 22. So use a calculator if you need to. I'd hate for you to get these problems wrong because you're messing up with adding positive and negative numbers, all right? Then I'm going to divide by negative 11, and what am I going to get? I'm going to get y equals negative 2. All right, so now I know half of my answer. I know that y is negative 2. All right, what about this one? 4 minus 6. Well, 4 take away 6 is going to be negative 2x. And over here, I have 19 minus 33. Again, feel free to use a calculator. 19 minus 33 is going to give me negative 14. And if negative 2 is equal to negative 14, when I divide both sides by negative 2, I get x is equal to 7. So now I know that x is 7. This one, by the way, y was -2. Here x is 7, so I know half my answer. On this one, once again, those cancel. 6 minus a -10. Again, be careful. It's not 6 minus 10. Look carefully what we have. Whoops, we lost it. Look carefully what we have. We have 6 minus a -10, right? I'm going to clear all this out. 6 minus a -10, right? And when I do that, I get 16. 16y equals, this one is 17 minus 9. 17 minus 9 is 8. Now be careful on this one. A lot of times when students are doing this problem, they're going to tell me that my answer is 2. But it's not 16 divided by 8. It's 8 divided by 16. So what do I get? I get y is equal to 1/2. So for each of these ones, I now have half of my answer, right? So for this one, I know what y is. For this one, I know what x is. And for this one, I know what y is. And then I'd go back to my original equation and plug it in. Now again, when I said original equation, I really should have said original equations, because just like last time, we can use either the first equation or the second equation. So I have two equations. Now when I started, I didn't know what x and y were. But what do I now know? I know that y is -2, right? So I can go to either equation, and I'm going to use the first one, 6x minus 3. I don't know what x is. I don't know what x is, but I know what y is. So I put -2 in there equals 6, right? I get 6x plus 6 equals 6. All right, subtracting 6 from both sides and dividing by 6, right? I'm going to have 6x equals 0, so I get x is equal to 0. Wow, that's pretty bad, Mr. Reeves. I get x is equal to 0. All this writing is making my hand go numb. All right, so I have 0, -2. Now, what would a good math student do? A good math student, we use the first equation. He or she's going to check it in the second equation real quick. 6 times 0 plus 8 times -2. What is that going to give us? Well, 6 times 0 is 0. 8 times -2, what do we get? We get -16. What were we supposed to get? -16. What did we get? We got -16. So the answer to this one is 0, -2. All right, well, I'm not going to go ahead and finish these problems because I did 3 already, and this last process is the same, using substitution to find the answer, right? So once you know what x is, plug it into either equation and find y, and then check it with the next one, right? We know y is 1/2. We could plug it into this first equation and find y, and then check it with the second equation. So again, the second method of elimination is subtraction. How do you know when to subtract? You look for these terms that are the what? The same. So when you see two certain terms that are the same, you're going to subtract, because subtracting the same thing always equals 0, right? When we see two terms that are the same, when we see two terms that are opposites, we're going to add, because adding opposites always equals 0. So again, this method is called elimination because elimination eliminates one variable. It eliminates it either using addition when the terms are opposite, or subtraction, right? Subtraction when the terms are the same. All right, so we're going to look at elimination with multiplication in our next video. I hope this was helpful to you. Have a great day, everybody. Bye.